In this video, we are going to find the area of the polar curve r is equals to a into 1 plus cos theta between the points theta is equals to 0 and theta is equals to pi by using double integration. Hi, I am Syed. Welcome to my channel Educate with Syed. Let's get started. Find by double integration the area enclosed by the curve r is equals to a into 1 plus cos theta between the points theta is equals to 0 and theta is equals to pi. Let us first try to plot the graph for this r is equals to a into 1 plus cos theta for the values of theta lying between 0 to pi. Any given curve is said to be symmetric if f of r comma theta is equals to f of r comma minus of theta. So if this condition is satisfied, that means when theta is being replaced by minus of theta, we get back the same curve. Such type of curve is a symmetric curve. Let us try to see whether this given curve is a symmetric curve or not. So let us take the function as f of r comma theta to be equals to a into 1 plus cos of theta. Now let us try to replace the value of theta by minus of theta. So replace the value of theta by minus of theta. So we get f of r comma minus of theta is equals to a into 1 plus cos of theta is being replaced by what value? Minus of theta. So minus of theta. So this will be equals to a into, it is 1 plus, what is the value of cos of minus theta? Cos of minus theta will be cos theta itself, right? So if you try to replace this cos of minus theta as cos theta, is it not the same curve f of r comma theta itself, a into 1 plus cos theta? So therefore we have got back the same curve f of r comma theta. So whenever you have f of r comma theta to be equals to f of r comma minus of theta, then we can say that this given curve is a symmetric curve. Therefore we can say therefore r is equals to a into 1 plus cos theta is a symmetric curve. Is a symmetric curve. And it is symmetric between what points? He has already given the points. Symmetric about the line theta is equals to 0 and theta is equals to pi. So let us try to see what type of curve this is. R is equals to a into 1 plus cos of theta. So we'll take theta, then r is equals to a into 1 plus cos of theta. Since theta lies between 0 to pi, we'll try to take the values of theta over here. Let me take the value of theta to be 0, 0, pi by 3, which is 60 degree, then pi by 2, then we'll try to take 120 degree, 2 times of pi by 3 and pi, which is 180 degree. Now let us put the value of theta is equals to 0 in this given curve. So we get r is equals to a into 1 plus cos of theta value is 0. That is nothing but a into 1 plus. What is cos 0 value? Cos 0 value is 1. So therefore we get 2 times of a. So the value of r will be 2a. Now let us put the value of theta to be equals to pi by 3. So we get r is equals to a into 1 plus cos of theta value is pi by 3. It is a times of 1 plus, this is cos 60 and we know cos 60 is half. So which is nothing but 1 plus half will be 3 by 2. So it is 3 by 2 times of a. So the value of r is 3 by 2 times of a. Next, let us put the value of theta to be equals to pi by 2. So we get r is equals to a into 1 plus cos of pi by 2, which is nothing but a into 1 plus, it is cos 90. And what is the value of cos 90? We know that cos 90 is 0. Therefore, we get the value of r to be a. So, we got r to be a. Now, let us take the value of theta to be equals to 2 pi by 3. Therefore, the value of r will be equals to a into 1 plus cos of 2 pi by 3, which is nothing but a into, it is 1 plus cos of 2 pi by 3, which is cos of 120 degree. If you can write down the value of cos of 120 degree directly, you can go ahead and write. If not, you can further write down this as pi minus pi by 3. Cos of 2 pi by 3 can be written as pi minus pi by 3, which is nothing but a into 1 plus, this in the form of cos of 180 minus theta, and the formula for cos of 180 minus of theta will be equals to, now cos of 180, whenever you get 180 and 360 degree, the trigonometric function will remain the same, cos theta itself. But when you want to write cos of 180 minus theta, where does this 180 minus theta lies? 180 minus theta lies in the second quadrant. In the second quadrant, cos is negative. Therefore, we will be getting minus of cos theta. So, hence cos of 180 minus theta will be minus cos of this value pi by 3. Now, this is nothing but a times of 1 plus into minus will be minus cos of pi by 3, that is cos of 60. What is cos of 60 value? Cos of 60 is half, or further we can simplify this one. 1 minus half will be half, so half times of a, we can write that as a by 2. Half times of a is a by 2. So, we got the value as a by 2. And then now I have to put the value of theta to be pi. So, let us put the value of theta to be pi. So, we get the value of r to be equals to a into 1 plus cos of pi, which is nothing but a into, it is 1 plus cos of pi, that is cos 180. So, cos 180 value is what? Cos 180 value will be minus of 1. So, you have to remember that cos of pi, cos of 3 pi, cos of 5 pi, and which cos of all odd multiple values will be equals to minus of 1. But when you go for cos of even multiples of pi, cos of 2 pi, cos of 4 pi, cos of 6 pi, and so on, its value will be equals to plus 1. Therefore, we get over here as a into, this plus into minus will be minus. So, this will cancel out, we get the value to be equals to 0. So, the value of r will be 0 when the value of theta is pi. Now, let us try to plot this one, and we have shown that the value of r is symmetric about this initial line theta is equals to 0 to pi. Now, this is the initial line that we have. Here we take the value of theta to be 0, and as we move here, the value of theta will be equals to pi. Now, we have shown that the curve is symmetric about this line 0 to pi, which means that whatever the type of curve that we get above this line, the same mirror image you get over here. That means the figure above this line and the figure below this line will be the mirror image of itself. Therefore, I will just try to draw the figure above this line theta is equals to 0 to pi, and then draw its mirror image below. So, when theta is 0, the length over here is 2a. So, theta is equals to 0 represents this line. When theta is 0, what is the value of r? R represents the radius, the length over here. So, I need to measure 2a. So, just measure the length from here. Suppose if I am taking this as the origin, from here you need to measure the length 2a, alright. But here, since 2a is just a constant, you can just take the measure 2a to be equals to 2 units, because a represents some constants, some constant times of this a. So, suppose if I am taking a as 1 over here, then 2 times of 1 will be 2 units. So if you want, you can just plot it over here as this is 1 unit somewhere over here, and this as another unit, 2 units or 2 centimeters you can write. So therefore 2 units, the length of r is 2 units. At this point you have theta is equals to 0. The next one you have theta is equals to pi by 3. Theta is equals to pi by 3. You need to measure the angle just by keeping over here. Pi by 3 represents 60 degree. So taking this as the initial line, measure 60 degree and plot it. You will be getting somewhere over here 60 degree. You can just measure over here. So you can just measure over here and write down. So somewhere over here you will be getting 60 degree, right? But how to write down this length? For 60 degree, what is the length that you are having? It is 3a by 2. So 3a by 2 is nothing but 1.5 times of a. So you need to plot this length 3a by 2. So if you want to plot this length 3a by 2, suppose if I am taking a as 1 unit, then you will be getting 1.5 unit. So if you are taking 1.5 unit as 1.5 centimeters, you can just measure from here and then write down that particular length. Suppose if you are measuring from here to here, you are getting the length to be equals to 1.5 over here. This angle is nothing but your pi by 3, 60 degree. Next, let us take the next angle that you have is pi by 2 for 90. For 90 it is the length a. So for 90, so 90 degree here, theta value is 90 degree over here. And for theta to be 90, the length from here, the radius that you have to take is a. So from here you can just measure, a is just 1 centimeter, you can just measure as 1 centimeter over here. Further we have 2 pi by 3 is 120. So 120 is a by 2. So from here you can just measure 120 degree. From this point you can just measure 120 degree. Somewhere over here you will be getting 120 degree. Measure. And what is the length you are having? The length that you are having is only a by 2. A by 2 is half. So a by 2 represents what? A by 2 is, a is taken as 1, so it is half unit. Half unit means 0.5. So you can just measure 0.5 and write down over here. Then further, for 180 degree, the value of r is 0. So 180 degree is this length, r is 0. R is 0 means this point, the origin itself. Now if it just try to draw a smooth line, so we get this particular curve. Similarly, in the same way, you can just draw its mirror image over here at the bottom. So this is the figure that you will be getting, and this figure is a heart shaped figure. Therefore we name this figure as a cardioid. So therefore we have got a cardioid over here. R is equals to a into 1 plus cos of theta. So if you try to observe what is this length r over here, r length I have taken from here to here, it is a, and from here to here the length that we have taken is a. So the total length that we have is 2a. And what about this length? This length is a. Corresponding to its mirror image over here, it will be a. What will be the limit values over here? Limit values for theta that we have. Theta is starting from 0 to pi. So it is a constant limit we have for theta. Then r should have a variable limit. So let us write down the variable limit. So initial value of r is starting from 0 itself, the length 0 to, since I want the variable limit, I will take the variable limit for r to be a into 1 plus cos of theta. So we have got the limits for r and theta. Now let us try to find out the area. So the area enclosed by the cardioid can be expressed as the double integral. The area in the polar coordinate is always represented in the form of double integral of r times of dr d theta. So this is the formula for the area enclosed by a curve in the polar coordinates. We have seen in the case of the Cartesian coordinates, the area enclosed under a closed curve is represented as double integral dx dy. But for the polar coordinates, we write down in this form double integral r dr d theta. Now let us write down the limit values over here. The limit values, theta will be 0 to pi, the constant limits outside. Then you have integral of r is equals to 0 to a into 1 plus cos of theta. So this term will be as it is, r dr into d theta. So let us first integrate with respect to r over here. Integral theta is equals to 0 to pi. Integral of r will be r square by 2. So the limit values for r will be r is equals to 0 to a into 1 plus cos of theta times of d theta, which will be nothing but this 1 by 2, the constant you can take outside. Then integral of theta is equals to 0 to pi. Apply the upper and lower limit values. R in this case will be a into 1 plus cos of theta, and it is squared, r square. Upper limit value minus the lower limit value for r will be 0, times of what we have, times of d theta. This will be equals to, it is half times of integral of theta is equals to 0 to pi. So let us try to square this one. It is a square. This 1 plus cos theta can be written as 2 cos square theta by 2, and whole square will remain as it is, times of what you have, times of d theta. So 1 by 2 as it is, you can take this a square outside. Then you have integral of theta is equals to 0 to pi. You can square this one. 2 square will be 4. Cos square whole square will be cos power of 4 times of theta by 2 into d theta. So this will be equals to, so 4 will come outside, is 4 times of a square by 2. Integral of theta is equals to 0 to pi. It is cos power of 4 times of theta by 2 into d theta. So let us try to integrate by substituting theta by 2 as some t. So put the value of theta by 2 to be equals to, say, t. Then let us try to differentiate this one. So derivative of theta will be d theta by 2. Derivative of t will be dt. Or d theta will be equals to, cross multiply this 2, it becomes 2 times of dt. And also let us try to change the limit values over here. If theta is equals to 0, so put theta as 0 over here. So what will be the value of t? The value of t will be 0. Suppose if I take the value of theta to be equals to, so this upper limit value, theta as pi. So what happens to this t value? T value will be equals to, you have theta by 2. So theta value is pi, so it is pi by 2. Further we can cancel out this one, 2 1 times and 2 2 times. Therefore we have a to be equals to, it is 2a square. It is integral of, the value is t is equals to 0 to pi by 2. It is cos power of 4 times of theta by 2, I have taken it as t. D theta is nothing but 2 times of dt. However, this 2 is a constant, you can take the 2 outside, 2 times of 2 will become 4. 4a square, it is integral of t is equals to 0 to pi by 2, it is cos power of 4 times of t into dt. We can integrate this integral by using the beta function. We know this formula. Integral 0 to pi by 2 sine power of p times of theta into cos power of q times of theta into d theta is equals to half times of beta of p plus 1 by 2 comma q plus 1 by 2. Now let us try to compare this integral value with this one. So there is no sign over here, so let me try to rewrite this one. So a will be equals to, it is 4 times of a square, it is integral of t is equals to 0 to pi by 2. So sine power of, since there is no sign over here, can I write this as sine power of 0 times of, or theta is not there, t is there, accordingly I can write it as t. Sine power of 0 times of t will be 1 itself. Anything to the power of 0 will be 1. So I am just introducing that one into this cos power of 4 times of t into dt. Here in place of theta we have t, so that will not affect the integral. So if we try to compare, here the value of p, that is sine power, over here is 0, and what is the value of q in this case? Cos power is 4. Now if you try to use it right hand side value, so area A will be equals to 4 times of A square. So what is the formula you have? Half times of beta into beta times of p plus 1 by 2. So p is 0, so 0 plus 1 by 2, comma q plus 1 by 2. Q value is 4, 4 plus 1 by 2. Let us further simplify this one. You can cancel out 2 1 times and 2 2 times. So we get the value as 2a square times of beta of 1 by 2, comma here the value will be 5 by 2. Now let us try to find out this beta function value. Let me take this as equation number 1. So we know this formula, beta of m comma n is equals to, so in terms of the gamma function we have gamma of m into gamma of n divided by gamma of m plus n. So therefore if I just try to plug in the values of m and here, m and n, so m value is 1 by 2, n value is 5 by 2. That is nothing but gamma of half into gamma of 5 by 2 divided by, it is gamma of 1 by 2 plus 5 by 2. So we know the value of gamma of half will be nothing but root of pi. So we know gamma of half will be root of pi. We need to calculate the value of gamma of 5 by 2. So to find gamma of 5 by 2, so let us try to find out this one. Let me take this as equation number 1. I will come back to this equation. So to find out this gamma of 5 by 2, we will try to use this formula, gamma of n to be equals to n minus of 1 into gamma of n minus of 1. So now if you take the value of n to be equals to 5 by 2, so it becomes gamma of 5 by 2 will be equals to this 5 by 2 minus of 1 into gamma of 5 by 2 minus of 1. So 5 by 2 minus of 1 will be 3 by 2 into gamma of 3 by 2. So again we are getting 3 by 2. Once again I can use the same formula. So 3 by 2 as it is. Let me use this formula. Now n will be 3 by 2. So it will be 3 by 2 minus of 1 into gamma of 3 by 2 minus of 1. So this is nothing but 3 by 2 times of 3 by 2 minus of 1 will be 1 by 2. So 3 by 2 minus of 1 will be 1 by 2. So this is nothing but 3 by 2 times of 2 is 4. And what is gamma of half value? Gamma of half value is root of pi. So we have got the value of gamma of 5 by 2. Further, I need to find out this gamma of half plus 5 by 2. So we have gamma of half plus 5 by 2. So it is gamma of, if I am taking the LCM, common LCM, you can just add the numerator values. So therefore we have gamma of 6 by 2, which is nothing but gamma of 3. So whenever you have a positive integer, for the positive integer we have gamma function as gamma of n will be equals to n minus 1 factorial. So if you try to use over here, gamma of 3 will be nothing but 3 minus 1 factorial, which is nothing but 2 factorial. 2 factorial is 2. So therefore this particular value, that is gamma of half plus 5 by 2, we got that value to be equals to 2. So let us try to substitute all these values back in this equation number 2. So equation number 2 implies beta of half comma 5 by 2 will be equals to. So what we have, gamma of half, that is root of pi into gamma of 5 by 2. So we have calculated the value of gamma of 5 by 2 to be 3 by 4 root pi. 3 by 4 root of pi, and whole divided by the denominator value, gamma of half plus 5 by 2 is 2. Further we can simplify this as 3 by this 4 times of 2 will be 8, root pi into root pi will be pi. Now we can substitute this value back in equation number 1. So equation 1 will imply, so this is your equation number 1. So we need to just plug in this value of beta. So a will be 2a square times of beta. A is equals to 2a square times of this beta value. Beta value is 3 by 8 times of pi. We can just cancel out this one. It's 2 1 times and 2 4 times. We get the value to be equals to 3 pi a square by 4. That's the area enclosed under the cardioid. Because it is the area, we can write that as square units. That's the required solution. If you like my video, please subscribe to my channel. Thank you.